Alright, so this video is about the number conversions. What I have right here, What I have right here is the powers of two tables from the exponential values to the results I got right here. We're going to use this to help us convert from binary to decimal and vice versa. So I made my first example right here. We're going to try to figure out how we get this to this. So to make this easier, you're going to count how many values you have. So right now I have 7. So 1, 2, 3, 4, 5, 6, 7 values. So we start right here. We're going to add up these powers of 2, but everywhere we see a 0, which is 1, 2, or from here to here, sorry, here to here, you just skip that, which gives me 103, and I also did this as well. This is the double check myself, and I got the same value, so therefore that's correct. And then we're going to do that again, just reverse. But instead of adding, we're going to subtract. Now, I decided to use the values right here instead for the second row. Since 512 is too big, I'm going to use 256. Subtract that, you get 171. Move up to the next small number, which is 128, which is 43. Since 64 is big, we can't use that one, so we have to use 32 instead. So for the same process, and then I also use this as well to verify myself, and then I got my binary number. Alright, now we move on to the octal side. Okay. So on this right hand corner right here, we have from 0 to 7. Then on these 3 columns right here, these are our binary numbers. From 0 to 7 as well. And I decided to make the example out of that. So, to make things easier, we just do like this. Go for the 3 numbers first on the right and see what they represent. So I got 101, and 101 represents number 5 right here, so I put the 5 right there. Next is 000, which is 0, so I put that as my next value. Now since I have 2 values right here, I just add the imaginary 0, which would give me 0, 1, 1. And that equals 3. That's how I got this value right here. And vice versa, we just do that backwards. So instead of going for the binary numbers, we just go for the actual numbers. Since the last one is 2, we go over here, which is 0, 1, 0, which I add right here. We do the same process to get the binary number back. Then my last table is the hexadecimal table. It's about the same process as the octal, except from the numbers 10 to 15, it will be represented as from alphabets A through F. And pretty much you do the same step, except going from 3, you do 4 instead, which is 1, 0, 1, 1, and 1, 0, 1, 1 would be right here on this slot, which gives me B, and do the same process to find my other variables. And once again, vice versa, just like how you did the octal to binary, you're going to do that same way. Just go to your right hand corner and find out what your number or letter represents as a binary number. Then just place those values right there, and then you're all set. And then that is it for your number conversions.